Heights and distances. Section 1. In here, the crucial thing that we got to understand is the interplay between angles and lengths under the geometric figure right angle triangle. And to see that, we use a model consisting of a circle and a right angle triangle, where circle is made up of unit radius and the right angle triangle is made up of the projection of this unit radius onto the x-axis when connected together. Now let's introduce two functions: sine, whose sole purpose is to spit out the value of the ratio opposite by hypotenuse; cos, second, whose sole purpose is to spit out the value of the ratio adjacent by hypotenuse, and both under a given angle of measurement. And in case if you are wondering about those opposite hypotenuse and adjacent mean, they are notations of different sides of the right angle triangle with respect to the angle measured. So opposite is the side opposite to the angle measured, and adjacent is the side adjacent to the angle measured, and hypotenuse is just hypotenuse. Now we have built up all the tools that we needed to actually study the thing that we are after for the interplay between angles and lengths in a right angle triangle, and it will be apparent once we make these two changes to our system. One, continuously changing the angle of measurement, and remember, this is our input to our functions. Two, scaling the whole system up and down. So through one, we understand that the output from those two functions fluctuate between -1 and 1, with cos starting its journey at 1 and sine starting its journey at 0. Now with 2, the scaling, we understand all it does is to stretch out the results obtained by those functions in proportion to whatever the scaling factor is. Okay, now we have gathered fair amount of understanding of how these two things are related to each other, and by seeing few functional values at few particular places, we will start section 2. So the functional values that we are concerned about lies at 0 degrees, 30 degrees, 45 and 90 degrees. Now moving to our unit circle, we can easily see the results at those particular places to be as this in case of sine, and to be this in case of cos. Now let's move to section 2. Problem 1. If the height of a pole is 2 cross square root 3 meters and the length of its shadow is 2 meters, find the angle of elevation of the sun. So let's just draw what he means. There is a pole of height 2 root 3 meters, then there is a shadow of this pole which measures to be 2 meters, and an angle of elevation, nothing but the angle which ground makes with the sun. Now to find this angle, we just use sine and cos, and we know that sine denotes opposite by hypotenuse and cos denotes adjacent by hypotenuse. Then by dividing them together, we should be able to answer the question by asking what should be the angle for this expression to be true, and the answer comes out to be 60 degrees. Problem 2. The angle of elevation of the top of a tower at a point on the ground is 30 degrees. On walking 24 meters towards the tower, the angle of elevation becomes 60 degrees. Find the height of the tower. Step 1. Laying out the picture. There is a tower, let's say height to be h, and there is a point which makes an angle of 30 degrees with respect to the top of the tower from the ground. And when it moves a distance of 24 meters towards the tower, the angle changes to 60 degrees. Step 2. Find the relation and solve. Here we will use a new function called tan. In fact, we have already used it in our previous problem when we divided sine by cos. We will do the same here for those two right angle triangles, which will give us the distance of the point away from tower before and after moving in terms of h. Now as we know the before and after distance along with the actual distance moved, we can easily find out the h by equating distance of the point after travel with distance before minus actual distance traveled. And this should answer the question. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.